Welcome to lesson 3, and this lesson we're going to start to learn to take control of our program. Now, if you did the last lesson, we ended up at the end of the lesson in using the main loop, and we were printing out the value of Q, and then the value of Q was being increased. We waited a very short period of time, and then we did it all again. And the result of that is that on our serial monitor, mine's still going here, we're up into the 2000s, the value of Q keeps on increasing. But unfortunately, that's all it's doing. I'm not in control, I'm not actually making any decisions, the number just increases. So in this lesson, we're going to learn about control structures. And the first control structure we're going to use is if. Now, when I was a kid, if got used all the time by my parents as a control structure. So a classic example would be, if I was good, I would get my pocket money. Else, if I was bad, I would go to my bedroom and I'd be staying there. If I was a good boy, I would get an ice cream. If I was a bad boy, something else would happen. So all of us in life have at some point been part of a control structure that uses if. Now, of course, on the Arduino, we don't use the ifs in quite the same way as my parents used to use them, but we will use what is called a comparison operator. And at the very basic level, if you can imagine, if we've got our series of numbers that we've seen going up, so the value of Q is increasing, we might have a situation where we say, if that number is less than 10, then do this. If the number is equal to 10, do something else. If the number is greater than 10, do another thing. So a comparison operator is something that's a little bit of code that says, take this one value and see if it's equal to the other value, and you'll see that being explained in the code. Now, as part of that, what we're going to do is look at something called a variable, and the variable we will look at is the integer variable. Now, we saw that at the end of the last lesson when we started to use Q to hold a value. Now, very simply put, a variable is something that can change its value throughout the running of the program. And one of the simplest ways to think about it is a parking space in a car park. So the parking space might have nothing in it. So at that point, if you like, the value of the value is 0. And then we could have a certain car come in and we could give that a number. We could change it. We could put another car in. So all the time it's a parking space, but the contents of the parking space, and in this case it's a number, an integer, is constantly changing. So we shall have a little look at that today and start to understand a bit more how that works. And the other bit that we're going to do is we're going to look at how to name a variable. So with that, I'm going to swap over the screens and let's get started with some programming. Okay, the IDE is started up and I've connected my Arduino Uno COM port 26. That's good. Yours will be a different number, but as long as it's not COM port 1, you are connected. Now, in our last lesson, we finished up at the bottom in the main loop, printing a string that said val space Q, and then we printed the value of Q. Now, Q was an integer up here, and we then increased its value by 1, which is what the plus plus symbol does. We then had a delay for 100 milliseconds or 0.1 of a second, and then it goes around the loop and does it all again. And the result is that in the serial monitor our value of Q keeps increasing. Now, great as that is, and it was a good example to learn to print things to the serial monitor, but we're not really taking control of the program. That value of Q is just increasing and could get more and more out of control. In fact, if we left it running, it would actually start to cause some issues, as we'll find out in some later lessons. So we're going to start off by saving our file, and this time obviously it's not serial print. We're going to move out and we're going to create a new folder, and I'm going to call it Control Structures. Whoops. And then in that I'm going to create a file called if else v1. Then of course when I come back to my script, a few days have gone by, been busy, so in here if else v1, and our purpose is to learn to use the if function. So in this script we're just going to learn how to use if. So again, take that name up there, paste it down here. Again, quick run through. We start the serial connection, we then print out our name, and then we print a blank space and we start to see our values appear underneath. Now if you remember, Q was an integer, and it's a bit of a weird one. How do I choose the name Q? Well, to be honest, I could have chosen any name, and that's something that we need to start to think about. So we'll just put in here choosing a name. Now what I tend to do is, if it is just a value that I'm using and I'm gonna, if you like, throw it away, I'll just use a single letter. Now the reason for that is, if I use a single letter, the chances of me misspelling it are much smaller. So if you look at code that I tend to write, if it's a variable that I'm going to throw away, I'll tend to use Q, then I'll use W, and then I'll tend to use an A or an S. I tend to use just single letters at the left hand side of the screen. But this could have been completely different. I could have called it my number. Now notice that's a lot longer, and one of the things in C++ programming is that there is a sort of, they would call it a good practice to naming a variable. Again, I don't think anything's going to break if you do it the wrong way, but what you tend to do is, if you're using a long name, you tend to write it, the first part, with a lowercase letter, and if it's two words joined together, notice there's no space in there, no funny characters, the second word tends to start with a capital. And very often we will choose a name to suit what we are doing. So for instance, if we had a sensor that was sensing distance, we might call it int my distance, and it's just choosing a name that, as you use it through the program, makes sense for what you're doing. Obviously in this situation we don't need a long explanation because it's just a number, so we're going to call it Q. But when it comes to choosing a name, we'll just put in here, start with a lower case letter, if a second word, no spaces, but start with a capital letter. Okay, and then we'll put carriage return. I'll put another comment line in, examples below. Now, if I don't comment these lines out, basically what has happened is I have created some space in memory. If you like, I've created 2 parking spaces for an integer, but at the moment there's nothing parked in the parking space. It's just empty. So if I leave those in there as the examples, it won't make any difference to our code. However, in general, you do not want to be leaving variables that you don't use, so we try to get rid of them as much as possible. Now, if we go down to our loop at the bottom, we will see that before the numbers were just increasing and increasing and increasing. And if I switch back to my serial monitor, as you can see, as I talk away, the numbers are still increasing. So let's imagine that we don't want that number to keep increasing. So what we're going to do is we're not going to let it increase to a number larger than 10. And this is where we start to use our if. So at the moment we have a value of q. Q increases by 1, and then we delay and it goes around and Q increases again. So what we're going to do is we're going to set a condition. So what we're going to say is if Q is greater than 10, Q equals 0. Okay? So what we're now doing is we're saying that if Q gets to a value, and that's the sign for greater than. So let's put a comment in there. That symbol means greater than. Okay? So what we're saying is if the value of Q becomes greater than 10, then we're going to change the value of Q to 0. And so what we're going to now do is I'm going to compile that piece of code. Wait the magic seconds while it does its business. And then we will switch to the serial monitor. And there you go. Now look what's happening in our code. Let's just stop it there. We see it goes 1, 2, 3, 4, 5. In fact, if we go right to the very beginning, hang on, that's the old bit that was on there before. In fact, I'll start it again just so it makes it clearer. So I'm going to start again, and there you go. Now I'm going to stop it there, so it's still increasing. But if we look, the first value we had was 0. Now, if we go back to our system, when we started with integer q up here, if you remember, the parking spot was empty. So the value in the parking spot is 0. So when we come down further here, the first value that will get printed out is 0. Now, if we go back to our serial monitor, you'll see then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then what happens? It goes back to 1. So let's jump back to our window again and see what happened. So what we said was if ever the value of q gets above 10, and what number comes above 10? It's 11. So the value of q increased, it went round the loop, we printed out the value of q, which had now got to 11. We then tested it, the condition, with our greater than symbol, and what did we find? Q was now greater than 10, so we made Q equal to 0. Now, if we go back to our serial monitor, you would think, well, if we made the value of Q 0 after it was 11, why is the first value we see 1? Well, if we nip back to our code, we'll see that when we increased Q, straight afterwards we increased the value of Q. So Q became 0, then we added 1 to it, we had a delay, it went round the loop again, and all of a sudden we printed the value of Q out again, and the value we printed out was therefore 1. So what you are looking at there is your very first control structure. Now, as an experiment, change the value from 10 to 1. Well, we won't go to 100 because it'll take too long to run. I'll just change it to 20. But what we'll do is we're going to copy that bit of code there. I'm going to paste it below, and then remember how we did a block comment, / multiplication symbol, / so now that code has gone light grey. So we've got the same code. I'm going to change it to 20, and we're going to upload it to our Arduino. I'm going to open the serial monitor. There we go. And there we go. Stop the scroll. And you can see we started at 0 as we did before. We print the value of the empty parking space. Our value keeps increasing until it gets to greater than 20, so it becomes 21. We reset it to 0, but we immediately add 1, and down we go again. So when you have done that, you have actually taken control of your first program. So if you've managed that, congratulations. So now what we're going to do is we're going to start to learn about some other comparison operators. If we bring up the manual, we go to Help, Reference, and if you go down the left hand side, we've got control structures, which is our if and if else that we're looking at today. If you go further down, we've got the comparison operators, and these are the different ones. So there is 2 equal signs in a row, which is equals to, exclamation equal, not equal to, less than, greater than, and then less or equal to, or greater or equal to. Now what we're going to do is write a very short sketch that's going to use all of those different comparison operators. So let's save our sketch. So we've got a new version. If else v2. Change that to 2. Where are we? v2. And this time we're going to let's just remove those because they're bad practice. We don't want to have unnecessary variables knocking around. And now we are going to remove this bit of code, and we're going to uncomment our other code. Now, one thing that's always important there is it's very easy when you're doing this to leave the end comment, the end of comment in. So don't forget, if you remove the one at the front, remove the one at the end. Okay, let's think of some comparison operators. So at the moment, all we're saying is if the value gets to greater than 10, we're going to change the value to 0. So let's start to think of some other comparison operators that we could put in. We'll move that back there so that our comment's in the right place. So let's put an idea in here. So think through the comparison operators in the reference if you ever want to look back to it. So the first one, if Q is equal to 4. And what we'll make it do is we will serial print line Q equal to 4. Sorry, missed the brackets out. Make it into a string. There we go. Now, an important thing to notice here, we call this equals to, and a little note, and we call it an important note. Q is equal to 4, not the same as Q equals 4. Q is equal, what we're doing here with the 2 equals sign, we're saying does Q equal 4? If we put this Q equals 4, what we're actually saying is change the value of Q to 4. So this just says is Q equal to that number, and if so, do something. Whereas in this bit of code we're saying change the value of Q to 4, and it's what we see here. When our value of Q got greater than 10, we changed the value of Q to 0. So what we're doing here, we're saying if Q equals 4, then print out this bit of information so that we can see that it's right. And what we'll quickly do is print that out to the serial monitor. So if I switch over screens, you can see the screen scrolling along. If we stop the scroll, you can see that we get it there. Value of Q is 1, 2, 3, 4, and when it gets to 4, going back to our other screen, it says okay, Q does equal 4, so now I'm going to do something, and at this point we've told it to print out this little string of text. Now at this point we could have been telling it to turn a motor on, we could have been telling it to turn a motor off, turn a light on, all different things. So at this point we have taken control of the program, and what I'm going to quickly do is type in a few other examples. So if Q is not equal to 4, let's just copy and paste this to make things quicker, and just put in there not equals. So now if we run our script, so all that's that moment, what do you say while it's compiling? There we go, we're starting to see information coming up, and as we can see, in virtually every case it says 6 is not equal to 4, 5 is not equal to 4, but when we see 4, of course 4 is equal to 4, so we don't get the not equals, we get the equals instead. And as an experiment, I'm just going to copy and paste some variables that I saved earlier just to save us some time. So I'm going to paste these in here, and we'll just go through them one at a time. So here Q is not equal to 4. In this next one, Q is smaller than 4. Here Q is smaller or equal to 4. And finally, Q, sorry, it's a mistake there, that should be a greater than. Q, that's right, trying to run a broadcast and type at the same time in program, it's not always easy. So Q is greater or equal to 4. So we've got some different versions there, we're using the various different comparison operators. Notice the one that I didn't use, we've got smaller than, I didn't use greater than. We've already used that and it's in our code. So we're going to compile this bit of code and see what comes out on our serial monitor. Let's start it, ready to scroll, and I'm going to stop it there and we'll take a look through at what is going on. So let's scroll right up to the beginning and see the different values as they came through for the first time. So when the value was 0, Q was not equal to 4, Q was smaller than 4, and Q was smaller and not equal to 4. Then we get 1 and we get exactly the same again. We get 2, we have the value 3, and now we get the value 4, and all of a sudden Q is equal to 4, Q is smaller or equal to 4, and Q is greater or equal to 4, because of course, as we've said, 4 is equals to 4. It's as simple as that. When we go to 5, it's not equal to 4, but it's also greater or equal to 4. So as you can see, by running that small script, you've actually now got an example of using every single comparison operator. So in this very small program, you can see how each time we're trying to build on the previous script, and in this one you've now seen how to use all the different comparison operators. So again, if you've got that far and you understand it, congratulations. If you don't understand at this point, what I'd say is go back, have another look, and start to play some games with these codes. Change these numbers. Obviously, if you make it higher than 11, in this particular example, nothing's going to happen at all. If you made this 20, some of these might work, so you might have something with smaller than 20, but you're never going to get the greater than 20 to work. So try and keep a number within the range and you'll see what happens. So have a little experiment, and once you've done that, we'll come back and we'll do the next file. Well, hopefully by now you've had a little bit of an experiment and you've tried the different comparison operators. So now we're going to save a new version of our sketch. So save as version 3. And this time, the purpose of what we're going to learn is we're going to learn to use the if-else function. Now, the difference, what we've seen at the moment is we're saying if our value Q is greater, smaller, or whatever, so we compare it, and if it matches the comparison, then we do something. Now the difference is with the if-else method is that we say if it matches this, then do this, but otherwise do something else. So it's a bit like me when I was young. My parents would say, you know, if you are a good boy, you will get your pocket money, else you go to bed early. So on one side we get one result and we go one direction, otherwise we go another direction. Now a little bit more just before we start this section. We've talked about integers, and at the moment I've just sort of said it's a number, but actually it's not just a number. It's a number that is in a certain range of numbers. And I'm just going to copy a little bit of text in here so that I don't have to type it all out again. So an integer, or an int, which stands for integer, is an integer, and that is a number that has any value between minus 32,768 and plus 32,767. Now, if you remember, I gave you the idea of the variable being a sort of a car parking space, and it's a case of it can put any sized vehicle in there that will fit within the space. But if it doesn't fit within the space, you've got a problem. So if you've got a little parking space for a car and you try to park a truck in it, it will overflow the boundary of the parking space. So the parking space for an integer is minus 32,768 to plus 32,767. Basically what would happen if we had our bit of code that went Q++ and we just left it and it kept counting up and counting up, if it got to 32,767 and it increased by 1, it would overflow its parking space and go immediately to minus 32,768, and it would start to then decrease before it then got to 0 and it increased in number. Now you'll notice it goes to minus 32,768, but only plus 32,767, and that is because this goes from minus 1 to 32,768, whereas on the plus side it doesn't start at 1, it starts at 0. So that is why there is a 1 difference between the minus value and the plus value. So that's just a little bit of information about the integer, and it starts to show why it is important in our code to have control of our numbers that we're using, because if we allowed in our code for that number to go over a certain amount, rather than our program suddenly counting up, it would suddenly go a massive negative number. And if you've got the time to do this, you could just use one of our first sketches and just change it and just leave it and watch it in the serial monitor, and guess what? It will get to that point where it suddenly goes minus. Now, most of the time we don't need to worry about it because we don't use huge numbers, but there are times when we do, and you'll see later on when we start to use about different variables that contain different types. So this is an integer, but there are other types of variable that, if you like, are a much bigger parking space. Some of them are a much smaller parking space, but we'll look at those in a later lesson. But just for now, just that little reminder that there are limits to the amount that you can get in the parking space for an integer, and those are the limits. Right, just noticed another terrible spelling mistake. So let's get started, and we're going to use the if else. So I'm going to just change a few little bits of writing so that it's correct. And what we're going to do for now is, rather than destroy everything that we've done, I'm just going to comment out this bit of code here, and you'll see why in a bit. I'm going to copy that out. So at the moment I've now reduced it to if Q is equal to 4. I want it to print out Q is equal to 4. And now we're going to use our else. So else copy this in. Just have it to get it in a nice, I like my code to line up correctly. Q is something else. Okay, so when we now run our code, We wait patiently again. Hang on a sec. Talk about being caught out by your own errors. I've had to take a little bit of a break between those two sketches, and what did I forget to do this time? I forgot to plug in my Arduino. I'm just going to try and bring this error message up. So guess what error I got? If I just lift this window, hopefully you can see it. I got an error there, error opening COM port 26. What we need is the noise. So there you go. It just goes to show anybody can get this wrong. So when you do make that mistake, then there we see it, that ARV dude can't open the device. Okay, going down. Let's try and compile the code again with the Arduino plugged in. Three, two, one, go. There's our code coming up. I've stopped the auto scroll, and we'll just look through what's going on here. So here we see Q is equal to 1, so Q is something else. Q is 2, something else. 3, something else. Q is 4, it's equal to 4. So if we go back to our code, we can now see that we've got an if statement and an else statement. Now, what you can do is you can do what we call a nested if else type statement. So what we could do now is we're going to use some of this code that we've got down here. And we're going to put this in here. Hence the reason I didn't comment it all out. Put that in there. So I've got two other different comparisons using other if statements, and I could use an if else statement within here. So what we could say here is if Q is greater or equal to 4, serial print that, but then I could also say within that, if Q is equal to 5, serial print line Q is equal to 5. So here, if you like, so we have an if else statement. I'm just going to use one of the magic tools here, which is auto format. And pressing auto format helps us to make sure that we've got all the end brackets in place. So I can see I've got my one if statement here, another if statement here, and that sits within the else statement. I've got an if statement here, and that sits within that if statement. So notice what we're doing here. If Q is greater or equal to 4, we'll change that to Q is greater or equal to 4. But so it'll always print that if it's greater or equal to 4. But if it happens to be equal to 5, it will print this line of code, and then it will print this line of code afterwards. So this is the first time, if you like, that we've got a decision that's been made that's then going to do two different things afterwards. And I'll start the compiler and we'll see how we get on. So our values are shooting up the screen. I'm going to shut off the auto scroll for a moment so we can have a look what's happening. So let's find a 1. So if q equals 1, we can see from our original if statement it's not greater or equal to 4, so it doesn't print that line. Because it's within that if statement and it hasn't agreed with the comparison operator, it also doesn't use that if statement. Now the else statement is if it's not equal to 4, so if it doesn't match this operator, it'll then say, well, does it match this, and does it match this one? Or so we see for the 1, q is not equal to 4. Let's just transition this over. In fact, I'm going to try and get a picture of the whole screen so you can see both at the same time. Hope the text isn't too small. So if q has a value of 1, we then see it print q is not equal to 4, q is smaller than 4. So we see it's delivered both of those statements. We then see with 2 it does the same, with 3 it does the same. When we get to 4, it's now going to match this comparison operator because it's greater or equal to 4. Just get rid of that line because it's going to be a bit confusing at this point. And it then said, but it only does the greater and equal to 4. When we get to the value of 5, then it says, yes, I've printed that the value is greater or equal to 4, but now the second if statement, q matches our comparison operator, and it says, great, q is equal to 5. So if you think about this, we could tidy up this code and run it again. In fact, I'll save it as a further version just to show another way that you can do this. Go back up to the top, change the 4, change the 4, and now we're going to learn nested if else nested if else. And we're going to go down, and where we had the q is equal to 5, I'm now going to put an else in here, and we're going to move this serial print, and we're going to paste it in here. So now instead of it printing out every time a number is greater than equal to 4, it will only print it out if it's greater or equal to 4 but is not equal to 5. And we'll quickly compile that one up. I'll switch over to the slightly easier to read view. Click the scroll button. Here we go, we're scrolling along, stop the scroll, and so we see, as before, we'll have to go to the bigger page view again. So as we see, we've got the value is 1, so it's at this moment it doesn't match our first comparison, so it's using the else statement and seeing if it now matches those comparison operators. When we get to 4, the first thing we see is it doesn't match that comparison because it's not 5, so it uses the else statement and it prints out that line. On the next line, q equals 5, so it meets the if requirement and it prints out this line and doesn't print out the else line instead. Now, as you can see, this can get a little bit confusing, and you can finish up with one line inside of another. It can actually become very, very confusing at times, and there are some other methods that we can use to control our code that we'll look at, because if you can imagine, if we nested one if inside another if and another if else, and it went on and on, our code could become extremely deep in values, but it could actually become quite unreadable and unusable. So for that, there are some other methods that we can use to control the flow of data, and we'll look at those in a later lesson. So as we think about what we have done today, we've taken control, we've used the control structure if and if else. We've learnt to use all the various different comparison operators. We've learnt a little bit more about the integer. We now know the minimum, the lowest number it can be and the highest number it can be. And we understand that, if you like, that's the limit to its parking space. It cannot have anything bigger in there. And if you remember, we've also looked at how to name a variable. So we've got that idea, you know, if it's a short thing that's being used all the time, use something like q. If it's something where it's measuring a specific distance, you might call it my distance or ultrasonic distance, where usually the first word will start with a lowercase letter and the second word with a capital letter. So I hope that's been helpful for you, and as they say in all of these videos, you know, if you enjoyed the lesson, don't forget to click the like and subscribe buttons. But even if you don't do that, I hope that we see you soon in lesson 4. Bye for now.